Today we're going to talk about how to determine whether or not a function is one-to-one, or in other words, whether or not it passes the horizontal line test. To complete this problem, we'll look at several methods we can use to determine whether or not the function is one-to-one. In this particular problem, we've been asked to determine whether these two functions are one-to-one. Keep in mind that that's the same thing as asking whether or not these functions pass the horizontal line test. A function can be called one-to-one and passes the horizontal line test if there's only one x output value for every y input value. So it's really just the opposite of the vertical line test. To solve a problem like this, we have to show that every x input value gives a different y output value. And if we have two different x inputs that give the same y output, then we know that the function is not one-to-one. So for example, with a function like f of x, where we have f of x equals x squared minus 2x, if we factor this, factor out an x and get x times x minus 2, if x is equal to either 0 or 2, the result will be 0. So what we're saying is that if we plug in 0 for x, we'll get 0 times 0 minus 2, which will give us 0. If we plug in 2 for x, we'll get 2 times 2 minus 2, which will also give us 0. So what we said is that we can plug in either 0 or 2 for x, and both of those answers, both of those values, give us 0 for an answer. So because we've plugged in two different x values and gotten back the same y value, we know that this function is not one-to-one. If we look at our second function, g of x, it's really easy to see that no matter what value we plug in for x, we'll always get a unique answer back for y. Because if we plug in -1, 0, 1, 2, 3, 4, any value here for x, this function will return a different value for y. So we know right away that this function is one-to-one. Another way to evaluate this is to assume that g of a, or you could do this with our function f of x too, in which case you'd have f of a, but that g of a is equal to g of b. If g of a equals g of b, we know that a also has to equal b. So if we can show that by plugging in a to g and b to g and then getting a to equal b, we can show that the function is one-to-one. So what we say here is if we plug in a for x and b for x and set those equal to each other, we'll get 1 over a equals 1 over b. So you're just plugging in a to your function, plugging in b to your function, and then setting those two things equal to one another. If you can do that and then solve this equation to get down to the exact equation a equals b, then you know that your function is one-to-one. And of course we can do that because here, if we multiply both sides by a and then multiply both sides by b, we'll get b equals a. And so we know that our function is one-to-one. So that's another trick you can use to figure out whether or not the function is one-to-one. You can also always use the graph of the function if you have it or if you know what it would look like to determine whether or not the function is one-to-one. Obviously this function here with f of x, we have an x squared in the function, and we know that functions with an x squared are going to have a parabola like this in the graph, and we know that obviously a parabola would not pass the horizontal line test because we can draw a horizontal line that will cross the graph at more than one place. So it crosses the graph at two places, so we know that it wouldn't pass the horizontal line test and therefore wouldn't be one-to-one. So that's it. That's a couple ways to determine whether or not a function is one-to-one, or in other words, whether or not it passes the horizontal line test.